The digital space is a world of connection and opportunity. Take this moment, for example.
The web has made it possible for you to enroll in this program, where you will learn from the personal stories of developers at Meta.
By the time you have completed this professional certificate, you can become a creator of digital experiences. Connection is evolving, and so are you.
You might not have a background in tech at all, and that's okay.
Even if you have no experience, this program can get you job ready within a single year.
So how can this professional certificate prepare you for a job at an organization like Meta?
The Android Developer Professional Certificate will help you build job-ready skills for a cross-platform mobile development role while earning a credential from Meta.
From Meta engineers, you will learn about how they collaborate to create and test responsive, high-performance mobile applications.
You'll also discuss interesting topics with other aspiring mobile developers
and complete a range of coding exercises to improve your skills. It's important to complete all the courses in the certificate in order,
as each course will build on your skills.
Although we have a recommended schedule for each course, the program is entirely self-paced,
which means your time is your own to manage.
As you make your way through the courses in this program, you'll learn how to code interactive interfaces using HTML, CSS, and JavaScript. You'll then dive into the world of React,
a widely used JavaScript library that was created here at Meta.
And its mobile version, React Native.
Next, you will learn to code in Kotlin, which is a very popular programming language used by most Android developers to create fast, reliable mobile applications. You'll also learn to work with data and use the Android Studio to create fully functioning mobile applications. For your final project, you will create a well-designed, high-performance Android application for your portfolio,
complete with interactivity to showcase during your job search.
You'll also be ready to collaborate with other developers, as you will have learned to use Git and GitHub for version control.
If you're hoping to operate independently or in smaller teams, not to worry. We've also got you covered when it comes to the basics of user experience.
You'll learn how to research a user's needs, create wireframes using popular industry tools like Figma, and design interactivity.
In the final course, you will prepare for the coding interview. You'll practice your interview skills, refine your resume, and tackle some common coding challenges that typically form part of technical job interviews.
Once you complete the program, you'll get access to the Meta Career Program's job board,
a job search platform that connects you with over 200 employers who have committed to sourcing talent through Meta certificate programs.
Who knows where you will end up? Whatever the future of connection looks like, you'll be part of its creation. Let's get started.
Hello and welcome to this course on Android mobile development. Today, practically everyone has a smartphone, with Android and iOS serving as the two dominant operating systems. In fact, it's understood that smartphones running the Android operating system held over 70% of the market share in 2021, and this was expected to increase over the forthcoming years. Additionally, everybody who has used one of these smartphones has utilized a mobile application. But how many of us genuinely understand what an application is, how it functions, or how important application development is to our daily lives? A mobile application can be simply defined as installable software that utilizes your phone's hardware to function on a smartphone device. Of course, that explanation gives a simplified explanation of how a mobile application operates. Let's quickly go over a few common use cases for mobile applications to give you an understanding of how they would work in the real world. For example, mobile banking uses applications to transfer, apply for credit, or complete transactions. Social media companies use applications to allow users to access pages, photos, profiles, and much, much more. Applications for online retail stores let you browse, order, and schedule goods deliveries while also saving your personal information for later purchases. These services are provided by mobile apps that are created specifically for your smartphone's operating system, using the hardware and OS that are at its disposal. Mobile applications can be developed to perform a variety of functions. Hence, Android developers should be familiar with programming languages like Java and Kotlin, have an understanding of the development tool Android App Studio, and an understanding of its application components like activities and services. But if you don't fully comprehend any of these concepts, don't worry. You're only getting a quick introduction to Android application development right now. You'll learn more about these ideas throughout the course, as well as completing other assignments that will aid you in becoming a mobile app developer. You'll learn about what a mobile app is and gain an understanding of the difference between mobile apps and mobile websites. Learn how a mobile OS works and be able to explain the operations of a mobile OS. Additionally, you'll learn about Java and Kotlin and how software developers utilize them to create a variety of apps for a variety of devices, including Android, web, embedded systems, server apps, and more. You'll explore the Android Studio interface and learn how to navigate its folder structure. You'll learn about the many parts of the Android Studio and how to use them to build your apps. You'll also get to build your very own application by creating a fully functional video player app, acquiring talents that are in demand worldwide. But don't worry, you are not expected to be an Android mobile developer just yet. There are many videos in this course that will gradually guide you towards that goal. Watch, pause, rewind, and re-watch the videos until you are confident in your skills. Then, consolidate your knowledge by consulting the course readings and put your skills into practice during the course exercises. Along the way, you'll encounter several knowledge quizzes where you can self-check your progress. And you're not alone in considering a career as an Android mobile app developer, which is why you'll also work with course discussion prompts that enable you to connect with your classmates. It's a great way to share knowledge, discuss difficulties, and make new friends. To be successful in this course, it is helpful to commit to a regular approach to learning. You need to keep committed to your learning and, if possible, create a schedule with dates and times that you can devote to your study. It's an online, self-paced course that allows you to study when and where you choose, but regular study patterns do help many students to learn better. In summary, this course provides you with a complete introduction to Android mobile application development and forms part of a program of courses that will lead you towards a career in mobile application development. Over the past few decades, the number of applications or apps being built has grown rapidly. But have you ever wondered who is responsible for developing such apps? Well, they're referred to as mobile developers. With the demand for mobile developers projected to grow exponentially in the next few years, I'm sure you're interested to know more about the role of a mobile developer. In this video, you'll learn all about that, including the responsibilities of a mobile developer, the kinds of languages and skills mobile developers have, and where mobile developers work and their job roles. So, what kinds of things does a mobile developer do? While no two roles are the same, there are many common tasks and responsibilities shared by all mobile developers. First is designing, building, and maintaining mobile applications. This includes tasks like building a user interface, or UI, based on design specifications, writing code to support functionality, and building animations and transitions to provide an engaging user experience. Other common tasks include integrating third-party application program interfaces, or APIs, to connect the app with other technologies or code, writing tests, and releasing apps and updates to the Apple and Google stores. Apart from the many coding tasks, developers also often work as part of a team, which can include other developers, project managers, quality assurance or QA professionals, and designers. In fact, as a mobile developer, you may find yourself working with multiple teams. As teams and development projects become larger, version control becomes increasingly important. Version control is a system that allows a development team or teams to track and manage changes made to the software code. Version control also allows your team or teams to work simultaneously and collaboratively on projects by enabling access to the most recent version of the software code. GitHub is one online platform that can assist you with version control. Amongst other things, GitHub makes it easy for you to keep track of your and others' work and review code changes in collaborative projects. It allows you to access and navigate between different versions of online files. Mobile developers also often play a role in planning projects and participate in the project progression by attending regular team meetings. In addition, you'll find that almost all mobile developers spend some time researching their projects and keeping up to date with emerging trends regarding their operating system, whether Android or iOS. Many of a mobile developer's tasks and responsibilities involve coding. So, what other skills do they need to develop mobile apps? Well, one of the most important is knowing the language that their app's operating system or OS software development kit is built upon. In the case of Android developers, this is Java or Kotlin. iOS developers use Objective-C and Swift. Being proficient in such languages can make you more capable as a mobile developer and can expand your choice of job roles and projects. Other valuable skills for any mobile developer who builds the user interface or UI for mobile apps are design and user experience or UX, as well as knowledge of server technology and continuous integration or CI. This is the practice of automating the integration of code changes from multiple contributors into a single software project. Okay, let's say that you have mastered your mobile development skills. Where in the job market do you find work? Well, because mobile development skills are in demand, there are many roles available. For instance, there are many developer roles in a large companies such as Meta. As the creators of React Native, mobile development is very important to Meta. Anyone considering a position at Meta will understand that knowledge of the React Native framework is a common requirement for their software engineers. Let's explore some of the job options available to mobile developers. Mobile development is popular with small companies and startups who understand how apps can aid their growth. It is equally useful to large companies. For instance, they may want to build apps that help them gain a slight competitive advantage, foster engagement with their user base, or allow their customers to quickly access their products and services. You can also use your skills to work as a freelance mobile app developer. If you are not attracted by any of the many job options available to you, you may prefer to start your own development company. With mobile development, you can take your own ideas directly to the market. You should now have a clearer understanding of the role of a mobile developer, their responsibilities, and the skills they require. I hope you're feeling excited about the opportunities being a mobile developer has to offer and eager to learn more about what Android mobile app development entails.
As of January 2022, Android OS accounted for more than 70% of the share of mobile operating system market. That means that as an Android engineer, you will be building for more than 2/3 of the world. Hi, I'm Stepan Fordey. I'm a full-stack engineer at Meta, working on Ads Manager, one of the world's biggest ads platforms. I hope in this video you will learn about what the day in the Android engineer's life looks like. I took up Android engineering when I saw how quickly Android operating system was growing. Thousands of different device models came to market and became very popular all around the world. It was very interesting to be building for this new and growing platform. Typical Android engineering requires a lot of collaboration with other people, designers, user research managers, and even iOS engineers. So be prepared to collaborate and communicate a lot. There is definitely some technical skills that are particularly important to Android engineering. Android is a very quickly growing platform, and not all of the parts of the ecosystems keep up with that. That means that sometimes there is issues that you need to get prepared to resolve. So debugging and understanding the concepts are by far the most important skills an Android engineer needs to master. Over the years, Android grew a lot and accumulated a lot of different approaches and patterns to solve the same problem. This diversity can be overwhelming at first. So it takes a lot of time to build an understanding of concepts, but it's very important to do that so that you can make sense of it and make the right calls as you grow and learn all of these different approaches and frameworks. If I were to relive my first year as an Android engineer, I would definitely love to work in a big company with a lot of other experienced and skilled Android engineers. Working with experienced engineers helps you understand what are the patterns that work best versus having to learn this by ear mistakes. That would save you a lot of time learning and become an expert much faster. As an aspiring Android engineer, I would advise you try as many things as you can, but take your time and learn and understand the concepts before moving on. Once you get this understanding, keep challenging yourself, keep pushing yourself outside of your comfort zone, and grow as much as you can. The Android platform keeps growing very fast and it keeps expanding to different aspects. It's not just the mobile phones anymore. Android is also in the cars, in home devices, even fridges. And Android is the platform of choice for new platforms like augmented or virtual reality. So an Android engineer can find themselves in a lot of different roles in a lot of different companies, and I can't wait to see how this plays out. Android engineering is very rewarding. Once you build the app and saw how it's used by the users of your product, you can see how it helps make people's life better and easier. And that's what makes Android engineering very fun.
As you progress through this course, you'll have the opportunity to create your own project in the development environment called Android Studio. So, let's take a moment to install Android Studio now. In this video, I'm going to show you how to download and install Android Studio. Although I'm using a MacBook, the download and installation process is similar for Windows and other operating systems. First, go to the official Android Studio webpage, developer.android.com/studio. This page has everything you need to quickly get started. It picks the operating system by default. So, because I'm running this website on a MacBook, it picks Mac OS. If you want to download on other operating systems, you can click Download Options. With this, you can choose between other alternatives for Windows, Mac, Linux and Chrome. Now, let's download the software Android Studio. Because Android Studio versions are bundled with Java Development Kit by default, you don't need to separately download and install Java on your local machine. When you click Download Android Studio, the terms and conditions are displayed, which you need to read and agree with. Then, select the correct version of Android Studio for your Mac, either Mac with Intel chip or Mac with Apple chip. The Mac I'm working on has the Apple chip, M1, so I select Apple chip. Downloading Android Studio may take some time depending on your internet speed. While waiting, it's worth mentioning that when you do create your own project in Android Studio later, you will use an emulator to run your project. An emulator conveniently allows you to simulate your app in Android Studio without needing to install the application on an actual physical device. But you'll learn more about this later. With billions of mobile users across the globe, mobile apps play a more significant role in the way people access information than ever before. While many businesses push their software products on multiple platforms, such as web and mobile, not everyone has the resources needed to build multiple solutions. In this case, and with the number of mobile users now surpassing desktop users, businesses may understandably choose mobile apps to reach their target audiences. So, with the demand for mobile apps increasing, it's important to understand mobile apps. In this video, you'll learn more about them, including the advantages and disadvantages of developing mobile apps compared to mobile websites. A mobile website is a website designed, developed, and optimized for mobile devices only. While mobile websites are designed to display and work on major browsers, they still require an internet connection and don't take advantage of the unique functionality of a mobile device. That's where mobile apps come in. A mobile app is installable software that runs on a smartphone device. Mobile apps use the device's hardware and software features and usually provide an efficient, more intuitive and seamless user experience. When choosing whether to develop a mobile app instead of a mobile website, one way to decide is to ask yourself this question: what specific actions do you expect your product to perform? For example, if you don't need your users to perform any operations and your product is mainly content-driven, then you may opt for a mobile website. But if you want users to perform actions that will require the device's hardware, you will need a mobile app. It is also helpful to understand the pros and cons of mobile apps when deciding whether to create one. The first advantage of mobile apps is that they are faster than mobile websites. They can also access the device or system resources, such as a location or Bluetooth, and can work without internet access. That said, mobile apps can be quite expensive to build and are more difficult to maintain when compared to mobile websites. Another disadvantage is that for a mobile app to be compatible with different platforms like Android and iOS, it is often required that it be built from scratch. It may also be difficult to have your app approved by the App Store if it does not meet specific requirements. You've now been introduced to mobile apps and the advantages and disadvantages of developing a mobile app compared to a mobile website. As you learned earlier, mobile apps are vital in the mobile development space. So I hope you're looking forward to creating your own app as you progress with your learning.
Did you know that Facebook, Messenger, and Instagram were among the world's most downloadable and used apps on Android? Hi, my name is Stepan Fordey. I'm a full-stack engineer at Meta, working on Ads Manager, one of the world's biggest ads platforms. In general, we try to launch features on both Android and iOS at the same time. This means that a lot of product teams have both Android and iOS engineers. As an Android engineer, you can expect to collaborate with the iOS engineers a lot, and you will learn about similarities and differences between Android and iOS quite a bit. You will also work as a part of a larger Android community, together with Android engineers from all of the teams at Meta. This will give you a chance to work together to improve the general code base, introduce new frameworks, keep them up to date, and build best practices. At the scale of Meta, the code base evolves quite differently from the smaller companies. There's different libraries and frameworks we built to support the operations. Some of them eventually become open sourced. Lito is a good example. It's a framework to build declarative UIs on Android that bring the famous React pattern from JavaScript world into Android development. Other libraries focus on meta-specific problems that other companies don't really experience. For example, managing dependencies between different libraries used at Facebook, Instagram, or Messenger. That kind of problems are typically not something that you face in a small company. So keeping the app size stable, prevent accidental regressions is something that we need to care about a lot at Meta, and we have a lot of products and frameworks tailored to serve that need. Moving fast is one of the Meta values. So this means that we always try to shorten the time it takes to build a product. We always try to keep quality high though, and the quality and the user experience is never a trade-off. Having said that, we try to launch products fast so that we can get feedback from our users, so that we see if the product works and if it really solves the problem we want to solve. And if so, we will invest more, or we'll take a step back and think, what do we need to fix? Working at Meta, you will test how far the typical design and user experience frameworks can scale. With dozens of different products that you need to fit in the app, like Facebook, for example, what are the frameworks that you need in order to keep all of these products accessible and discoverable for the users who need to use them? What are the different design patterns that you need to use? What are the trade-offs between them? Having these problems at scale makes the work here really challenging, but also rewarding when you finally arrive at a working solution. Be prepared to test the knowledge that you get and try to think of what are the limits to these frameworks, how scalable they are, and what you can do about it as you learn. Android engineering offers you one of the most diverse sets of career opportunities out there. Hi, my name is Stepan Fordey. I'm a full-stack engineer at Meta, working on Ads Manager, one of the world's biggest ads platforms. If you really like mobile engineering but aren't sure about Android versus iOS, the good news is that it's really up to you what to choose. In the modern world, both Android and iOS devices are vastly popular in so many different countries. What does that mean for the companies? It means that they need to ship products on both of these platforms. They also need both Android and iOS engineers to build these products. So it's really up to you which path you want to take. There is definitely trade-offs between them. If you want to take both Android and iOS, you will quickly learn about differences and similarities between these platforms, and you will have a good product understanding. What can you build as a mobile engineer? At the same time, it will take you much longer to build deeper expertise on both Android and iOS. If you focus on only one at a time, you will develop that expertise much faster, you'll become a bigger expert, and you'll be able to focus on deep technological problems and products. Mobile engineering role, and Android specifically, is very different between large and small companies. Working in a small company, you will likely need to focus on the entire app. You'll be building a user interface. You will be also managing the local state. You'll be working with the backend in your product. And you will likely participate in the product launch cycles. So you will have an experience working with everything that relates to Android. But you will likely have to spread yourself very thin. When you work in a large company, you will be most likely focused on just one product because it's impossible to comprehend the entire code base of a company like Meta. But you will dig very deep into the understanding of products and features you are building, what specific design libraries work and how they work under the hood, so that you can use them to the maximum advantage to make your product as successful as possible. Regardless of the industry, there is different career paths for an Android engineer. You can grow in depth and become an expert in Android, in its specific libraries, frameworks, or even in the Android itself. And you can eventually become one of the architects in your company and even help kick off new tech-heavy startups in things like AR or VR, for example. Another way for you to grow as an Android engineer is to be a full stack. You can start working with iOS, you can start building backends on even database layers, and you will know how different things work together. Full stack engineers are invaluable to bring different teams in a company together. You can also grow to a tech lead, a person who has a vision of the product and works a lot with cross-functional teams of designers, product managers, researchers. And you will be organizing this diverse team to execute on a bold vision of your product. As an aspiring Android engineer, focus on learning first. Expand your horizons, push yourself outside of your zone of comfort, and try new things. As you do that, try to think what motivates you, what makes you excited. And it will come very naturally to you which career path to take, the one that motivates you the most.
If you are looking to build Android applications or apps and position yourself in the mobile technology industry, then it's essential that you're familiar with the different programming languages you can use. In this video, you will explore two Android languages, Java and Kotlin. In the world of Android development, Java and Kotlin are both extremely popular programming languages. Java, which was released by Sun Microsystems in 1995, is one of the most popular programming languages in the developer community. Software developers use Java for a wide range of apps, such as Android apps, web apps, embedded systems, server apps, and more. For a long time, Android developers used Java to develop mobile apps because it was the only supported language. However, Android eventually needed a more modern language to complement the features of Java. This need inspired the development of Kotlin. Kotlin was introduced by JetBrains in 2011 and has since become one of the supported languages in Android Studio. In fact, over time, Kotlin has officially become the preferred language for Android app development. That's one of the reasons you'll be working with Kotlin in this course. Now, let's take a moment to consider some of the benefits of using Kotlin. In comparison to Java, Kotlin is concise and time-saving. It has simpler and fewer lines of code, reducing code errors and streamlining programming. Writing less code means that with Kotlin, it will be easier to maintain an entire project, regardless of its complexity level. Concise code is also easier to read and change. Another major advantage of Kotlin is that it is completely compatible or interoperable with Java. As a result, developers can use Java commands, libraries, and frameworks in Kotlin projects without any issue. Also, with a single click, you can convert Java code to Kotlin. Kotlin also addresses some of the common issues developers run into with Java. For example, it better handles errors that commonly cause crashes in Android apps. You have now been introduced to two Android programming languages, Java and Kotlin, and should have greater insight into why Kotlin has become the preferred language for Android app development. Keeping in mind the benefits of using Kotlin, I hope you are looking forward to working with this programming language when creating your own project for this course. As the mobile market continues to grow enormously, and with the demand for apps exploding, the mobile app creation business has never had more tempting opportunities. In order to successfully join this industry as an Android mobile app developer, you will need a good understanding of the tools and technologies you need to do things efficiently. Over the next few minutes, you'll learn about one of the mobile app development tools in the market, Android Studio. Google launched Android Studio in 2013. Since its launch, many developers have chosen it as their preferred environment for app development. Android Studio is Google's official integrated development environment, or IDE, for building apps that run on Android operating systems. It provides developers with features that not only improve the development of their apps, but also the overall quality of work. This IDE supports various languages for app development, such as Kotlin, Java, C++, and more with extensions. Before outlining the functionalities of Android Studio, let's take a moment to explore some of its key features. These include a complete build system, which will allow you to compile and build your Android app, a fast emulator that simulates Android devices on your computer for testing your apps on different devices, the ability to build apps for different types of Android devices, free project templates for quick development, and support for third-party integrations. Android Studio comprises essential tools that enable developers to deliver high-quality apps within a single environment. The toolbar provides a wide range of actions, such as running your app on an emulator or physical device. The navigation bar allows you to navigate and access project files. It gives a sleeker view of the structure visible in the project window. The editor window allows you to make changes to code. This is dependent on the existing file type. The tool window bar runs around the outside of the IDE window and gives you access to specific tasks like project management, search, version control, and more. It contains buttons that allow you to expand or collapse these individual tool windows. Finally, the status bar displays the status of your project and the IDE itself, as well as any warnings or messages. In this video, you've learned that Android Studio not only supports various languages for mobile app development, but also includes functionalities that will aid you as you start developing your own apps. In fact, there are even more ways that Android Studio can assist you with app development, which you can look forward to learning about later. When you start developing your own mobile applications or apps, being aware of ways to create apps efficiently will become invaluable. As you can imagine, the ability to get started quickly with app development is one of the things developers look out for when choosing a development environment for writing code. Luckily, many integrated development environments, or IDEs, ensure that there is at least a base code for any developer to use. They also offer developers a sneak peek at what a particular language has to offer. More specifically, these IDEs provide project templates that follow specific design principles and coding best practices to get you up to speed on creating beautiful functional apps. These code templates can be used to quickly create new app modules, activities, or other components of your project. Android Studio, which is an IDE used for developing Android apps, provides starter code for various basic implementations of the Android platform. With Android Studio, you can select from a wide range of app modules and class activity templates when creating a project. One popular use case of templates is adding new activities to an existing app project. For example, imagine you want to create a login screen where your users can log into your app. Well, with the login activity template, you can get that feature implemented in less time. Let's take a moment to explore a few of the templates available on Android Studio, namely the Basic Activity Template, Bottom Navigation Activity Template, and Empty Activity Template. The Basic Activity Template allows you to create a base code for your app that includes common user interface or UI components. This will form a base project to which you can add more code. If you ever want to use bottom navigation for quick navigation within your app, the Bottom Navigation Activity Template is the easiest way to get started with it. This activity lets your users explore and switch between top-level or key screens of your app with a single tap. The Empty Activity Template allows you to start building your app from the very beginning. No initial codebase is included in this template. This kind of template works best if you already have a project structure in place. Now that you know more about project templates, let's outline some of the benefits of using them. The first advantage of using project templates is that they offer a clear understanding of the project structure. The templates provide you with a structure that meets the best practices recommended by the operating system or OS manufacturer. Next, as mentioned earlier, project templates give you a preview of what the platform has to offer. This way, you can get insight into how things work behind the scenes before investing your time in learning how to build apps for that platform. Last but certainly not least, project templates allow you to build quickly. You can start building apps in minutes just by using inbuilt project templates. You should now understand what project templates are and be able to list some of their benefits. You've also been given a sneak peek at the kinds of templates available in the Android Studio and can look forward to learning more about what this IDE has to offer you as a future developer. When starting your career as an Android developer, one area you will need to understand is how Android projects are created in Android Studio. To help you get started, this video will serve as a quick guide to creating your first Android project. Although this integrated development environment, or IDE, is designed to perform several operations beyond just creating projects, in this video, the focus is just on how to use Android Studio to start your project. Notably, an Android project contains all the files that your IDE will need to build and generate your Android app. With the Android Software Development Kit, or SDK tools, which is a component of the Android SDK that includes a complete set of development tools for Android, it's easy to start a new Android project with a set of default project directories and files. Okay, so you've got to create a new Android app. Let's begin. In this video, I'm going to demonstrate how to start a new project in Android Studio. The first step is to launch your Android Studio. The Welcome to Android Studio window is displayed. In the Projects tab, your previously created projects are available. There are also additional buttons on the right-hand side. For now, let's focus on the New Project button. To create a new project, click on New Project. This opens a new window, which gives you access to many different templates for a range of devices, including phone and tablet, Wear OS, Android TV, and automotive. These templates come with a default code base that allows you to quickly get started building applications for different devices. Note that the No Activity option enables you to create a new project that does not include any default code base. For this video, let's select the basic activity template that works for phones and tablets. Once you've selected your template, click on Next. In the next window, you need to provide a name for the application. Let's call it Sample App. There's also the package name. You can leave as con.example.sample_app. The package name is unique to every app, as its purpose is to identify your app uniquely on the Play Store. You can also retain the Save location line, which refers to where you'd like your project to reside. Next, you are given the choice between the two supported languages in Android development, Java or Kotlin. Pick Kotlin, as this is the language you are going to use throughout this course. After that, you can set the minimum version of the SDK or Software Development Kit. Let's leave it at API 21. The API level is equivalent to the operating system version. API 21 means that your app will be functional for Android devices with an operating system of 5.0 and above. To create the application, click Finish. So here is the new Android project in the Android Studio environment. You can close any pop-ups if necessary. On this page, the project pane is on the left. It may take a moment to load. From the project pane, you have access to the project files that have been generated by the template and Android Studio. It contains different folders for app development. And that's how to create a project in Android Studio. You should now know how to launch a new project in Android Studio, a fundamental first step in creating your own Android apps in future. You are now ready to move on to exploring all the project files generated by the Android Studio environment and how you can use them when creating your very own project. Mobile apps have become integral to everyday life for most of us. In fact, there are millions of Android apps with wide-ranging purposes available for users to download. But, as an aspiring mobile developer, you may be wondering, what are the different components that go into making these Android apps? Let's find out by exploring the anatomy or structure of an Android app. An Android app is made up of 4 major components that serve as the building blocks of any Android app in the market. Each component has its own purpose and unique behavior. These major components are activities, services, broadcast receivers, and content providers. Let's unpack each of these major components in turn. An activity is a class considered an entry point for users that represents a single screen. It is like the window or frame in Kotlin. With the help of activity, you can place all your user interface or UI components or widgets on a single screen. For example, a music player app may have an activity that shows you a list of your favorite songs, another activity that allows you to play a specific song, and another which shows you a list of trending songs. Each activity is independent of the others. Then, there's the services component, which runs in the background, serving as the invisible background worker of any Android application. Its function is to constantly update the data sources and activities with the latest changes. It also performs tasks when users are not active on applications. A good example of a service is chatting with someone whilst listening to music. Another component is the broadcast receivers component. Its purpose is to respond to messages from other applications or systems in real time. To illustrate, imagine you are enjoying your favorite song on your music app when you get a notification that you're running low on battery power. Have you ever wondered how you get notifications like this? Well, broadcast receivers are responsible for such activities. This example is just one of many use cases of this component. Content providers is the last major component and is responsible for sharing data between one or more applications. This kind of operation is based on request. A typical example is a social media app that allows users to share their images online. The app can show you all the images from your gallery with the help of content providers. These Android components are coupled by a configuration file called Android manifest.xml. It is used to specify each component and how they interact with each other. Let's explore this configuration file. In Android Studio, I have the project folder for an example application, as well as its Android manifest file open. This is a configuration file that is required by all Android apps and defines the major components of the app. It also contains information about what the app needs in order to run on an Android device. One of the major components, activity, is defined in this file already. Currently, it has specified details such as name, label, and theme. However, let's further expand the file by defining another major component, such as a receiver. To do this, I'll start by adding a line below the activity block and typing receiver Android:name equals and then .receiver within quotes. I then end with a / and right angle bracket. Next, I can add a services subclass to this receiver by advancing to the next line and adding an indent before typing service Android name equals .service inside of angle brackets. Finally, let's add a content provider for this receiver. On the next line, I type left angle bracket provider and then follow with lines for Android:authorities and Android:name. I won't define the receiver component in detail in this example, but this should give you an idea of what type of information is typically expressed in the Android manifest file. For now, I'll delete the additions I've made, but later you'll explore how to use the Android manifest file in depth for configuring your application with all major components. You now know more about the major components that make up Android apps. Well done! You're making great progress towards creating your very own project in Android Studio. You've reached the end of this module on Introduction to Android. In this module, you've explored what a mobile app is and how a mobile OS works, received an intro to the Android languages, Java and Kotlin, discovered the steps for selecting and launching a project, and explored the basic structure of an Android app. It's now time to recap the key points and concepts you learned and the skills you gained. You began the module with an overview of mobile apps and explored how a mobile OS works. Following the completion of this first lesson, you should now be able to provide an overview of what a mobile app is, explaining the difference between mobile apps and mobile websites, and explain the operations of a mobile OS. You can now also explain the pros and cons of mobile apps to help you decide whether to create an app or not. And you can provide an overview of how a mobile OS works. Following your introduction to mobile platforms, you were then introduced to Android development. This final lesson focused on Android development and the programming languages it uses. During this lesson, you explored the programming languages of Kotlin and Java and were introduced to the Android Studio IDE. You can also now complete the initial steps for starting a project in Android Studio, and you can also explain the composition of a simple Android app. What a great start to your Android application development journey. You're now familiar with the basics of mobile application development. You can explain what a mobile app is and how a mobile OS works. You have an understanding of the programming languages that are used and can launch a project within Android Studio. Well done! With billions of mobile devices around the world, the demand for and use of mobile devices is high. As more new devices are released to the market to meet this demand, software engineers need to develop apps for them. As you can imagine, purchasing different types of devices to test these apps is not practical. That's where emulators come in. In this video, you will learn more about emulators, their purpose, as well as the types of emulators available. So, what exactly is an emulator? An emulator is a computer program that's designed to imitate another kind of device. While different types of emulators have unique ways of operating, the overall goal remains the same: replicating the experience of the original hardware or software. By mimicking the behavior of mobile devices, emulators allow you to test how your apps will run on the devices you have designed them for, without having to install them on the actual physical devices. For example, if you are an Apple user and you want to run an app specifically designed for a Windows computer, you will need to use an emulator. Emulation does, however, require high computing resources in most cases. This means that if you are going to use an emulator on your machine, it's important to make sure there's enough storage space and random access memory, or RAM, available for it to run effectively. And what types of emulators are available to you? There are several commercial and open source emulators available for most of the operating systems in the market. For example, emulators like BlueStacks, which is a popular and free emulator, allow you to run Android apps on operating systems like Mac and Windows. Another example is Appetize.io, a browser-based emulator that allows you to use iOS applications on any PC. Aside from running apps, some emulators even make gaming possible. For example, Super Nintendo Entertainment System, or SNES, classic console emulators allow gamers to play old video games on modern HD televisions. You should now have more insight into emulator software, what emulators do, and the different types of emulators available to you. Later, you'll learn how to configure and create an emulator in Android Studio, which will allow you to simulate your own project app. Although software testing has long been an integral part of the overall software development cycle, mobile app testing is gaining more attention. So, how is it possible to test and optimize all these different mobile apps developed for different devices and operating systems? Well, in this video, you'll learn about a feature of Android Studio that can help you with this: the Android Virtual Device, or AVD Manager. You can use the AVD Manager to ensure that Android apps are well optimized for different devices. More specifically, this tool allows you to define the various features of a physical device, such as an Android phone, that you want to create and simulate in the Android emulator. By creating and configuring these virtual devices, you can test your apps across multiple devices without necessarily purchasing physical devices. Now, let's take a moment to explore the AVD Manager available from the Android Studio IDE, or Integrated Development Environment. In this video, I'm going to introduce you to the Android Virtual Device Manager, or AVD interface. I'll start by opening Android Studio. To access the AVD interface, I go to the top right of the Android Studio environment and click on the three-dotted menu for more actions. Then, I select Virtual Device Manager. This opens a new window. On this page, there are two major features. You can create a device, and you have access to a list of previously created virtual devices. With each virtual device listing, which includes the device name and Android version, also referred to as API level, you can perform various actions, as indicated by the icons on the upper right-hand side. For example, if you click the play button, it will run the emulator on the virtual device you have selected. You can edit the device by clicking the pencil button. This allows you to edit and save any changes you make to the properties of the virtual device with the help of the device editor. There are also additional action options if you click on the triangular drop-down menu. These actions range from duplicating to deleting a selected virtual device. Now, to create a new device, you can click on the Create Device button. Once again, this opens a new window. Here, you can create and configure a new virtual device based on your specifications and requirements. You'll be able to select the physical device you want to emulate and set and edit any required properties. And that's an overview of the major features of the AVD interface, from launching an emulator on an existing virtual device to creating new ones. You've now had the chance to preview some features of the AVD Manager interface. Later, you will learn how to use the AVD Manager to create your own emulator. With the release of each new Android operating system comes new changes that offer security and performance improvements and enhance the user experience of Android as a whole. To make sure your app users have the best experience, it's essential to understand the dynamics of different operating systems. That's why, in this video, you'll be introduced to Android operating system, or OS images, and their role in development. Android OS images are just versions or copies of Android operating systems that are used by an emulator. With the help of these Android OS images, your app can leverage the features of any operating system in the market. For example, if you wanted to test the most recent releases, you could download the most recent Android OS image and run it on the emulator to experience the OS. Likewise, if you wanted to test your app against an older OS, you could, for example, download the Android Lollipop system image and run that. As a developer, through the OS images, you can enjoy the built-in features of an operating system using the Application Programming Interface, or API level. This is a whole value, like API level 30, that uniquely identifies new features that have been released for a particular OS. As the number increases, more functionalities are added. Currently, The most recent Android OS images available for developers in Android Studio range from version 8, codename Oatmeal Cookie, released in 2017, to version 13, codename Tiramisu. More specifically, after the release of Oatmeal Cookie in 2017, came Pistachio Ice Cream in 2018, Quince Tart in 2019, and Red Velvet Cake in 2020. These were followed by Snow Cone in 2021, Snow Cone V2 in March 2022, and Tiramisu. With each release of a new version, the API level increases, with the most recent OS image having the highest API level. Now that you know more about the OS images, let's explore how to access them in Android Studio. In this video, I'm going to demonstrate how you can access Android OS images on Android Studio. In the Welcome to Android Studio window, click the three-dotted menu icon on the upper right-hand side to access more actions. Then, click on the Virtual Device Manager. On the Device Manager page, click Create Device. This opens the virtual device configuration where you can create an emulator. You can choose from the different device categories, but let's continue with phone. You can then choose a device definition. The different devices are listed with information on things like their size and resolution. Let's pick Pixel 2 and click Next. This is where you have access to your OS image. So, once you select a device definition, you must then specify what type of image you want to install for that device. On this page, you have access to many images of operating systems, which are like copies of the different operating systems, such as API Level 33, if the target of your app is Android API 33. If you click on Download next to the release name of your chosen system image, it will download the selected OS. That's how you can access system images in Android Studio. Later, you will learn how to use your system image to run an actual emulator. You have now learned about Android OS images and how to access them in Android Studio, preparing you to use an OS image to run your own app through an emulator. Because running an app on an emulator is much like using an app on an actual mobile device, most developers are turning to emulators as a tool to test and even debug their app code. While emulators are a safe place to test code, especially at the beginning of the design phase, using an emulator on a computer does require some configuration to function properly. That's why, in this video, you will learn how to configure and launch an emulator. You can configure an emulator with the help of the Android Virtual Device, or AVD, in Android Studio. In particular, with the AVD, you can specify the interaction between the development computer and the emulator. Let's explore some of the AVD properties you are most likely to use when configuring your emulator in Android Studio. The first is the AVD name. You can use this to specify the name of the device you want to create. Then, there's Startup Orientation, which sets the orientation for the device. You can select either Landscape or Portrait mode. Another property you are likely to use is Emulated Performance. This allows you to specify the number of processor cores from your computer's hardware that you'd like to use for the emulated device. The more processor cores you use, the faster the emulator. You can also set the RAM, or Random Access Memory, in Memory and Storage, which is an advanced setting. Although the manufacturer sets a RAM value for the device by default, you can override this by specifying a new RAM value. As a note, the higher the RAM value, the more resources the device will consume on your computer. Now that you know some more about the AVD properties you may encounter when configuring an emulator, let's explore how to configure and create an emulator in Android Studio. In this video, you'll learn how to configure an emulator in Android Studio. In the Welcome to Android Studio window, access the Virtual Device Manager by clicking the three-dotted menu in the upper right-hand corner, then clicking on Virtual Device Manager. Although there are existing devices to choose from, click Create Device on the top left to create a new one. This will open the Virtual Device Configuration window, where you can choose the type of device you want to emulate. You have different device categories available to you, including TV, phone, wearables, tablets, and automotives. However, for this video, the focus is phones. You can select Pixel 2 XL and then click Next. On this page, you need to select the system image you want your device to run. This is a copy of an Android operating system that is used by an emulator. A system image called API32 is already downloaded. Although you have the option to download others, let's use API32 for the purpose of this demonstration. So, click API32 followed by Next. This takes you to the Android Virtual Device or AVD page, where you can verify the configuration of the device. You can name the AVD whatever you'd like. Using the Change buttons, you also have the option to change the device and system image that you selected earlier on. Next, you can choose to make the device portrait or landscape. Then, you have the Advanced settings, which allow you to customize many more properties. This includes the option to specify the RAM you want the device to run on, the internal storage, and even the additional memory and storage from an SD card. All devices in the market have these features. Although these settings can be changed, for this video, let's use the values already assigned here by default. And that's an overview of how to configure your emulator. You can then click Finish to create it. The Pixel 2 XL emulator is now available in the Device Manager. To run the emulator, click on the Play button. You may need to wait a few moments as it launches the emulator. The emulator pops up in a separate window. It looks exactly like an actual device because the Android system image allows you to experience the look and feel of any Android device available to you in the market, which is incredible. So here's your emulator device with different apps running on this system image. In subsequent videos, you'll learn how to install your own apps on this emulator. You should now know how to configure and launch an emulator. This is an essential skill for Android mobile app development, as you will likely use emulators to test and debug your own apps in the future. Constructing a house should start with the foundation. This is because, without a structurally sound, solid foundation, the house will likely be unable to withstand environmental factors and, over time, encounter serious damage. The same applies to mobile app development. When you develop an app, it is important that it is well structured, using project folders. These folders hold the different pieces of the entire project together. In this video, you'll learn more about these folders, specifically the folder structure of an Android project. Whenever you start a new project in Android Studio, it automatically generates many files and folders by default. These files and folders contain everything that is required for an app to run, from source code and assets to test code and build configurations. Let's unpack some of these basic files and folders made available by Android Studio. You already know that the navigation bar allows you to navigate and access project folders and files. Let's begin by exploring the Sample App folder. The Sample App folder is the root directory for your project. The root directory is, in essence, the root for all other folders and files. Next is the .gradle folder. Gradle refers to the build toolkit that guides the project building process called Gradle, which you'll learn more about later. This folder contains all the configurations and files used by Gradle to build your project. You can delete these files if you want, but they are automatically generated each time you try to compile a project. The .idea folder is used by Android Studio to store specific project metadata. The purpose of this folder is to tell apps how to use the data it describes. In this folder, there is a set of configuration files containing configuration data for specific functional areas. The name of these files indicates the functional area. For instance, compiler.xml, encodings.xml, and modules.xml. Then, there's the app folder, which contains source code related to the project. Here, you write your code, create the user interface or UI, and store assets such as images and fonts. After that is the Gradle folder. Gradle refers to Android's build system, which is a set of tools made available to developers to build, test, and run their applications. Whenever you build or compile a project, build-related data is generated and held in this Gradle or build folder. The Gradle folder contains subfolders and files. Let's review some of them. First, there's the .git ignore file. In this file, you will specify all the sensitive project files and folders that you may want to exclude from your repository system, such as GitHub. This means that these files will never be pushed to a repository system. Next is a build.gradle. This build file is used to specify and manage the configuration options common to all subprojects folders. GradleW is a file that is used by Gradle, Android Studio's build system. It is only created once and is updated whenever a new feature or plugin is required to build a project. Then, there's the local.properties file. This file contains information specific to your local configuration. For example, the path to the software development kit, or SDK. This is a file that you don't need to push into a version control system like GitHub because it contains sensitive local information. Last is the settings.gradle file. This file handles the various settings for projects and modules. Something else worth mentioning is the external libraries, which can be found in the app folder. It is not a folder, but rather a place where third-party libraries are displayed. In this video, you've learned about the folders and files that make up an Android project in Android Studio. This structure is vital in creating a successful app that ensures an excellent user experience. One of the most fundamental parts of an Android app is the activity class. Your app will have at least one activity class, no matter how small it is in terms of code and scalability. In fact, when you create your app in Android Studio, the main activity class is generated alongside other folders and files. In this video, you'll learn more about the main activity.kt file, which contains Kotlin code that is integral to the behavior of your app and is essential for your app to run successfully. But first, what is an activity? In Android, an activity, which is one thing a user can do, is an entry point for interacting with the user. This is where the action happens, because activities allow the user to interact with your app. An Android app is usually made of multiple activities, sometimes called screens, that together form the user experience. These activities are represented by an activity class, whose function is to respond to user input. Each activity class contains a layout that holds different pieces of a user interface, or UI, together so that a user can interact with an app. This means that the activity class is the gateway through which a user can interact dynamically with an Android app's UI. One activity in an app will be specified as the main activity. This is the entry point from which Android will run its program, as it's the first screen that appears when a user launches an app. When you create a new Android project using the main activity template in Android Studio, a file called mainActivity.kt is generated with some initial code alongside other generated files and folders. Let's preview this generated activity file in Android Studio. Let's begin to explore the file mainActivity.kt. I have generated a project called Sample App using a project template. As a result, there are different folders and files available under Project Files in the navigation bar on the left-hand side. One of the generated files is mainactivity.kt. This file is the entry point for your app, so it's very important in your codebase. Within this file, different parts of the Kotlin codebase are displayed. For example, at the top is Imports, where you have access to external packages and plugins. The next part is the main class, called mainActivity. In this area, different functions are displayed. The function I am going to introduce you to is the onCreate function. You will learn more about creating different activity classes with Kotlin using this function later. For now, it is enough to know that the onCreate function is the entry point for your app to run successfully. This function is called when your app is run. Its role is to create the view and initialize the actions of the activity. It is essential to have the onCreate function in your activity class in order to run an Android app. Other functions, such as the actions users will perform on the activity screen, follow the onCreate function. And that's a preview of the main activity file. In subsequent videos, you will learn how to use activities to create different classes and build an interactive app. You have now been introduced to activities and the activity class and previewed the main activity code in Android Studio. As you progress with your learning, you will discover how to use activity to create different classes and build an interactive app. Have you ever wondered how Android Studio compiles and runs an application project with different files and folders? Well, this is done with the help of Gradle, the subject of this video. With Gradle, the Android project is managed through a set of build configuration files. These define how a project is to be developed, what dependencies need to exist for the project to build and run successfully, and what the result or results of the compilation process should be. To start using Gradle in your app project, you don't need to install anything, as it comes with Android Studio by default. When you click the Run button on the Android Studio toolbar, this action automatically triggers Gradle activity, which, in turn, starts building the project. After a successful operation, your app starts running on an emulator or a physical device connected to the computer. For every Android project, 2 build.gradle files are generated. The first build.gradle settings apply to every module in the entire project, while the second set of project level or module level settings applies to only the app module. A module is a collection of source files and build settings that allow you to divide your project into different units of functionality. If there were another module within the project, then that module would have its own build.gradle file. The code displayed on screen is an example of a default build.gradle file. Let's examine this code more closely to get an overview of the Gradle structure for every application. The Android block contains information about your project, such as the minimum operating system or OS version you want your app to use for the compilation. The default config subblock allows you to specify the minimum OS version, version number, application unique ID, and other configuration settings. The dependencies block specifies what third-party libraries you wish to include in your app. If a local copy is not available, all specified dependencies are automatically downloaded for you. Now, if you want to have full control over your Gradle system, you can start your Gradle system manually through the command line tool. To do so, you'll need to know some Gradle commands, so let's explore some of the popular ones. The first command is /gradlewbuild. This is used to build a project when you are ready to run the application. A new build directory will be generated if it doesn't exist. Next is /gradlewclean. You can delete the contents of the build directory already generated using the clean task command. Finally, /gradle_w wrapper allows you to see all the available Gradle operations running in the background. That's your introduction to Gradle. You now know more about the role of Gradle and how it's used to create projects in Android Studio. In this video, I'm going to introduce you to the Android manifest file. When you create a new project, Android Studio generates a manifest for that project by default. This XML file contains essential information about your application, such as your activity, your receiver, and the services and providers. This will help you to define the permissions that your app needs in order to access protected parts of the operating system or other apps. Let's explore the different components of this file. First is permission. This permission tag allows you to specify specific requests for the application. So, for example, if you want to send an SMS with the application, you'll have to define that within the XML file. To do this, I open the tag, type users-permission, which is followed by Android:name equals. There are a variety of permission options to select from. But to send an SMS with the application, I type android.permission.send_SMS. You can also select this from the options and close the tag. So, when your application has been launched on the user device, it's going to request your permission to send an SMS with the app. This exemplifies what the permission tag is used for. Another component is the application tag. The application tag is used to specify the theme of the application in terms of the user interface or UI experience. You can define things like your icon and label in your application tag. Within the application tag, you will find activity. The activity tag is used to define all the activities that you're going to create across the application. For example, here is the default activity class, main activity, which you learned about previously. You may recall that this is essentially the entry point for your app. Within the application tag is a sub-tag called intent filter. This is necessary in order to specify this class or this activity as the initial point of running the application. In other words, the first page that is going to launch is the main activity class. That's why there is an action and category tag within the intent filter. The launcher category means that this class has been assigned as the first class that should run when your application is running on the user device. There are several other things that you can do inside this file, depending on the nature of your project. However, for now, I hope that this overview of what's inside the Android manifest file will assist you in defining essential information for your app in the future. In Android, almost everything is a resource. In fact, this is an integral part of Android development. Resources in the form of files and static content that your code uses, such as colors and animations, are contained in the resource folder in Android Studio. The resources in this folder can be referenced anywhere in your application code. In this video, you'll learn all about the different resources you can find in the resource folder in Android Studio. Let's jump right in by exploring 4 resources: string, color, dimension, and font. In most cases, you are going to display text in one or more places across your app. This text needs to be stored so that different parts of the app can access it. String resource gives you the capability to define the text in the res/values/strings.xml file. Each entry is a key that represents the ID of the text and a value that is the text itself. For instance, if I wanted text to display "Congratulations" on my app, I might add this string to the string resource file called strings.xml. Next is color resource. creating a beautiful user interface, or UI, comprises the use of the right combination of elements and colours. If you ever need to use colours across your app, the Colour resource helps you manage your colours so that they are easily accessible across the app. Colours should be defined within the file called colours.xml. Because you will likely use different sizes and dimensions for elements in your app, there's the Dimension resource. The Dimension resource makes it easy for you to manage all your size dimensions in one place. Dimensions should be defined within the dimens.xml file. Lastly, there's the Font resource. As you may be able to tell from its name, this folder is used to manage the fonts you use within your entire app project. All your font files should be added to the font directory. You may be wondering why resources are important for mobile app development in Android Studio. Well, building apps that can function effectively across multiple devices is crucial for ensuring the best user experience. For your app to support multiple device specifications, it's essential that you leverage the default resources within the resource folder. These resources play an important role in your app's device compatibility. For example, if your app is going to provide multiple language support, the resource folder helps you to define the languages. The app's language preferences are automatically selected based on the user's default language on the device. Also, if you want your app to be responsive across multiple devices, you can provide different layout resources based on the screen orientation and then specify one orientation as your default. Overall, providing default resources is essential, not only because your app might run on a configuration you didn't plan for, but also because future versions of Android sometimes include configuration qualifiers that older versions don't support. You have now learned about the resources contained in the resource folder. You should also have more insight into the importance of leveraging these resources to ensure app compatibility across different devices and ultimately enhance user experience. In this video, you're going to examine the res folder within project files. Amongst other folders, the res folder is generated at the point of creating a new project in Android Studio. There are various subfolders within this folder. For this video, you will learn more about the drawable and mipmap folders. While both the drawable and mipmap folders are used to store image assets for your app, mipmap is an upgrade that Google introduced as an improvement to drawable. So, I recommend that you use mipmap for app development. There are a few mipmap folders within the res folder. Let's examine the first folder, mipmap-nedpi-version 26. Just like the drawable folder, it contains different images and assets. However, using the mipmap folder is a simple way of providing a quality image and image scale within your app. In other words, using mipmap will help ensure that your app renders high-quality images across different devices. To understand this better, let's imagine an app user is using a Nexus 6 mobile phone. This device has an impressive resolution at about 2560 by 1400 pixels. In Android, this translates to 730 by 430 density-independent pixels. In order to maintain image quality when running on the Nexus 6 device, the app is going to select the image asset from the mipmap-xxx HDPI folder instead of the other folders. This is because it contains image assets of higher density and will work better on a device with a very high resolution. So, with mipmap, when you run your app, the selection of images is strictly based on the density of the device. In this mipmap folder, the image assets are 192 by 192 WebP, as displayed in the top right corner, where WebP is Google's image format, like PNG and JPEG, for example. Let's open another mipmap folder, mipmap-xx HDPI. The image asset quality is now 144 by 144 WebP. The bitmap folders contain the same images but in different sizes or densities so that when a user runs your app on their device, it retains the quality of the images regardless of the density of the device they are using. In other words, the aim of putting your image assets such as icons into bitmap is to ensure you retain high-quality visuals in your application. This means the images will not become blurry when the app is run on a device with higher density. You now know more about using bitmap in the res folder in order to render high-quality image assets in an app project. In this video, you are going to learn about the layout folder, which is one of the sets of folders generated as part of the project files when you create a project. The layout folder is used to manage the user interface or UI of your application. It contains 4 files with the extension XML, which stands for Extensible Markup Language. XML is used to declare and create UI in Android. Declaring your UI in XML allows you to separate the presentation of your app from the code, like the business logic, so that you have full control of the behavior of your app. That's why these files have been used to create UI. This makes it much easier for you to create different UIs for devices with different screen sizes. For example, I can create another version of the activity main.xml file to run on a different set of devices, ultimately creating a scalable, seamless app. This makes it easier to write scalable, seamless apps that can run on different devices. So, let's examine the activity main XML file. Within this, there is a hierarchy where you have parents and children embedded within the parents. And if you click on the Design tab, you can view what you have in your UI. This page allows you to see the visual representation of what you are writing and experience the different components you have for your app. So, imagine that you want to create a login page. In the Design tab, you'll be able to view the UI you have created. And in the Code tab, you'll have the code equivalent to the UI. You can also access different palettes and components in the Design tab, such as text for text fields and buttons for events. For example, if you want to create text, you'll click the text component. You can use this palette to create anything text-related, or a text input field like email or password. There are many things that you can do using the Design palette, whether you choose to write in XML or want to drag and drop elements. To illustrate, the palette allows you to drag and drop a button on your environment. This hasn't displayed correctly, as I'm not writing the code for now. So, you can undo the action with Ctrl-Z to remove it from the screen. And that's an overview of the layout folder. Later, you'll learn how to create apps using layout and XML, of course. You've reached the end of this module on emulation and development. In this module, you've explored what an emulator is and how to set up and configure its software, explored the Android Virtual Device Manager interface, and discovered the structure of a project and the folders involved. Let's now recap the key concepts and skills you learned during the module. You began the module with an overview of emulators and the AVD. Following the completion of this first lesson, you can now explain what an emulator is and how it requires high computing resources to run effectively, and understand how to set up emulator software. You can also demonstrate how to use the AVD Manager to ensure Android apps are optimized for different devices. And you explored the AVD interface to understand how to create a device and gain access to previously created virtual devices. In addition, you explored Android operating system images and discovered how they are used by an emulator to experience the OS, and received a demonstration on how you access Android OS images on Android Studio. And then you learned how to configure and launch an emulator within the Android virtual device, and explored how emulators are used to test and debug the apps you've created. Following your introduction to emulators, in the next lesson, you explored the Android Studio IDE and project structure. This lesson focused on the folder structure created and how Android Studio uses each of these. During this lesson, you gained an understanding of the folder structure and how Android Studio automatically generates files and folders by default, explored each of these within Android Studio, and discovered how external libraries is a place where third-party libraries are displayed. You also discovered how a fundamental part of an Android app is the activity class, and how a .kt file, which contains Kotlin code, is integral to the behavior of your app. You then discovered how Gradle helps Android Studio to compile and run an application project with different files and folders, and explored an example of a default build.gradle file. In addition, you learned about the various resources available to you in the resource folder before discovering how to examine the res folder within project files. Finally, you discovered how to navigate and use the layout folder to manage the user interface or UI of your application. Great work! You're making good progress on your journey toward becoming an Android application developer. You're now familiar with emulators, what they are used for, and how to configure them. You can also navigate and operate Android Studio and the folder structure. Well done! Developing an app can take a lot of time, and it is tricky to know where to start. The decisions you make before beginning your project will determine, to a great extent, the amount of time you will spend on coding or manipulating libraries or packages. Successful app development depends on good project planning. In this video, you will learn how to perform requirements gathering, an essential step in project planning. Project planning starts with getting a clear picture of what the project, or in this case, the app, is going to do. Once you have the idea clearly defined, it allows you to break the app down into principal components of functionality. No matter if the app is for yourself or for a client, requirements gathering is an important step that should not be skipped. Let's go through a simple requirements specification for a video player app. As mentioned earlier, an app normally starts with an idea. The idea in this case is to create a video player. But there are a lot of different ways to play videos. Think about streaming. Will the app have video art? Will it play one or multiple video formats? And what kind of controls will it need? You need to think about what exactly you want this app to do. These questions will guide you to determine what components the app needs to have to fulfill its envisioned functions. Some more questions you should consider are you going to build the video app yourself, or will it be a video selection app that sends videos to another app that plays them? Will the app store videos on the device, or stream them to the device, or gather links for selection? Let's say the answers to these questions are that you want a self-contained app with a player that stores MP4 videos locally and controls each video. With this information, you can further decide what platforms you want to use to develop the app, as well as which libraries or packages you will need. In this case, the app will run on Android. Finally, you have a complete requirement specification for your app. By now, you should understand that you will speed up the development time considerably if you carefully consider your options instead of diving straight in and guessing as you go. In this video, you've learned that no matter what app you're trying to build, you should always start with requirements gathering. The aim is to answer as many questions as possible to determine the needed components. The more complex the project, the more questions you'll need to ask and answer. But even a simple plan, like the example covered in this video, will save a lot of time and effort. Now that you know what the requirements of the proposed app project are, you can think about it from a more technical perspective. Building an application from scratch can be quite difficult and time-consuming. However, Developers have a wide range of templates available that can make this process easier in Android Studio. With these templates, you can quickly set up your video app project while you focus on implementing the main features. And the main features are that users can select, play, and pause a video. One popular use of templates is to add new activities to an existing app project. In this case, the basic activity template will be useful when you create your main activity screen where users can interact with the video player. The basic activity template allows you to create a base code for your video app that includes commonly used user interface or UI components you may need for the project. This will form a base project to which you can add more code to perform specific actions based on the project requirements. Let's review what else you know about the project. So far, you know that the app will be lightweight because you don't have to worry about images, music, or streaming video to the app. You know that you require play and stop buttons for the video, and you can create these using a clickable button. And you know that you'll need to select a video from the phone library, so you need an additional button in your app. Because you don't require streaming, you can use Android's Video View component as it allows you to just display a video file. And with only a few changes to the default build pattern, you can incorporate all the elements needed for your app. Now you can start to think about the next step, which is starting the project. You are ready to start creating your video player. Now that you know what the requirements are and you have your project plan in place, you can go ahead and launch Android Studio and start coding. When you launch Android Studio, on the first screen, click on the New Project button located in the top right corner of the screen. A window will pop up where you can select a template from a wide range of project templates. Because you are creating a mobile app, you should select the Phone and Tablet Templates tab. Select the Basic Activity template. This will allow you to create a base code for your app that includes commonly used user interface components. Now, create a new basic activity by providing a project name. Let's call it video_player. Every Android app has an application ID. This ID uniquely identifies your app on the device and in the Google Play Store. Once you publish your app, you should never change the application ID. If you want to upload a new version of your app, the application ID needs to be the same as what it was when originally published. If you attempt to make changes to the application ID, the Google Play Store sees the deployment as a completely different app. So, let's create a unique package name and call it com.example.video_player. Select Kotlin from the Language drop-down menu. For this project, you're using Kotlin throughout. Next is Minimum Software Development Kit, or SDK. This is the minimum version of the Android operating system required to run your video player application. Let's select API Level 23, which is equivalent to Android 6.0. Finally, click on the Finish button. And now you have a new video player project made using the basic activity template. You now have a basic main activity class, which will be used to display the user interface of your video player to the user. Apart from the main activity class, there are other files and folders that are generated alongside it. You have already learned about them in previous videos, so you're ready to move on to the next step, where you will learn more about Android's Video View, a component that allows you to simply display a video file. There are many video player apps available. Some are nicer to use than others. But what makes one app better than another? Well, for one thing, users like easy navigation. Elements like buttons and menus need to be in expected and logical places on the screen. So, to create an enjoyable user experience, you should try to design simple and intuitive mobile apps that are easy to navigate. Fortunately, Android Studio has many layouts that you can use to achieve this. In this video, you will learn about the different types of layouts you can use in Android Studio to build the first screen that appears when a user launches an app, the main activity. By now, you know that one of the basic components of an app is activities. Generally, an Android app contains one or more activities, and each activity is one screen of the app. And these screens will contain one or more UI components. The structure of these UI components is defined by layouts. A good example of this is the installed apps tray on your mobile. Layouts are comprised of a collection of views and view group objects. But what does view and view group mean? A view is Android's built-in view class. When this is used to create a view, it can be referred to as an object. It represents a rectangular area of the screen and is used for displaying information or content and event handling. Text, images, and buttons are all views on Android. They can be grouped inside another view, which can act as a container. View group is a special use of the view class because it can contain one or more other views. In other words, view group is used to define the layout in which views will be arranged on the Android screen. There are various layouts available in Android that you can use to implement a user interface with a distinctive design that is in line with the requirements gathering of the app. Earlier in this course, you covered Extensible Markup Language, or XML. Android layouts are written in XML. You declare a layout through a simple XML layout file located in the Resource Layout folder of any project you work on. When you create a project using a basic activity template, Android Studio generates a file called activity main.xml. Let's explore a few Android layouts that developers use regularly. First, you get Android Linear Layout. Linear layout is an extension of a view group which is used to render different child view instances such as text, button, and so on. This layout is used by setting the orientation to either a horizontal or a vertical direction, one after the other. Next is the Android Constraint Layout. Constraint Layout is a view group subclass that enables developers to position and size child views or widgets flexibly using constraints. These constraints make it possible to position a child view relative to other views on the screen. For example, you need to use constraints to constrain child B to the right of child A or child C to the top of child A and B. Another layout is Android Recycler View. This is a view group that can be used to display sets of data that can be scrolled. The item views inside the Recycler view are positioned using layout managers. For example, Linear Layout Manager displays items in a vertical or horizontal list, and Grid Layout Manager displays items in a grid. And then you get Android Web View. Web View is an extension of a view group which is used to render web pages as part of an activity layout. Next, you will explore a practical demonstration of how to create a layout XML file for the main activity within the video player project that was created earlier. I have the video player project open that I created earlier in Android Studio. Remember, when I used a basic activity template to create the project, a set of folders, including the layout folder, was automatically created. I will now create a simple activity file with no UI elements within the layout folder. I right-click on the layout folder, go to New, and then click on Layout Resource File. I call it Activity Main. Android Studio will add the XML extension by default because it recognizes that it is a layout file. I now have to specify the root element. The root element defines a particular view group that I will use to create all the UI components. For this screen UI, I have chosen the constraint layout. As I discussed earlier, there are different types of layouts, such as linear, relative, and so on. The constraint layout is an extension of the view group. I will use the constraint layout as the parent component which will hold all the other UI elements together. I click on OK to create the activity main file. Notice that the file is currently empty because it does not have any UI components yet. In later videos, you will learn how to add UI components within the constraint layout. By now, you should know what layouts are and how they are used in Android app development. You also learned how to create a layout file in the layout folder of a project. So far, you have a basic app with a layout for the main activity. You also have an overview of Video View class. Now it's time to concentrate on how and where your app will find the videos it must play. Android has a built-in class specifically for locating files. It's called URI, which stands for Uniform Resource Identifier. This is essentially the file path and the description of the resource you want to locate. A URI identifies a resource either by location, name, or both. Take note that a resource can be any type of file. It can be an image, video, or music file. Since I am building a video player, I will demonstrate how to find an MP4 video file. Let's open Android Studio to explore how to locate a video file with URI. Before I demonstrate how to find assets from within your Kotlin code, I need to add the video files to my project folder. Remember, I want to play videos within the app that I'm developing instead of selecting them from a user's device. To do that, I need to create a specific folder in which the video files can be saved. I right-click on the Res folder, go to New and select New Android Resource Directory. Notice that there is also an option that says Directory. What's the difference? When I use a new Android Resource Directory, Android recognizes all files saved there as resources and assigns unique IDs to each item. These IDs help Android identify a resource whenever a developer needs to reference it. On the other hand, a directory folder is just a regular folder, and Android will not assign IDs to the files saved in it. Next, I need to specify the resource type, which in this case is raw. Notice that the directory name automatically changes to raw when you select raw as the resource type. Click on OK. The raw folder is now in the res folder, and I can add a video file to it. I simply drag a sample video file into the raw folder. When you add assets, Android Studio will ask you if you want to change the name of the file. To keep the file name the same, click on Refactor. Test.mp4 is now in the raw folder. The question is now, how do you make a reference to test.mp4 from within your Kotlin code? I have the main activity Kotlin file open, and I will now paste a code snippet into it and then explain what it does. This code will make a reference to the file because it specifies where to find it. First, it specifies that it is an Android resource. Then, it specifies the package name, which in this case is com.example. And lastly, it specifies to retrieve the file test from this directory. Make sure that you do not add the file extension. Android automatically recognizes the file as a video file because it's added to the raw folder inside the Android resource folder. You should now be familiar with how to create an Android resource folder and add files to it. You should also now know how to reference files saved in this folder from within your Kotlin code. Later, you will learn how to create a video application and then play the video right within the application. In Kotlin, a single import statement can make visible a class or all classes for a built-in package within Android SDK. It is useful to a developer like you because you won't have to write an entire video player app from scratch. To speed up development, you will use a Video View class, which has already been added to Android's SDK. To access this and other helpful classes, you can reference it by using an import statement. You can write an import statement like this. The statement says that I want to use the Video View class included in the Android SDK. Now, let's take a more in-depth look at the imports you'll use for your video player app project. By now, you know that the video player video view class is used to play the video player in an application. So, you need to be able to make a reference to this in the Kotlin code. Here, you'll notice that I already have a few imports. These make reference to built-in packages already developed and built by Android that come with the Android SDK. Because they are built in, you can import and make reference to those packages. First, let's examine the URI. This built-in package allows you to reference the location of a particular file that you want to play. With the URI, you can either make a reference to a file that's already in your application folder, like, for example, within the raw folder here, or you can make reference to a file that is on the user's device, perhaps the external storage. Next is the media controller. This enables you to have access to the playback controls of the video player. This means the play, pause, backward and forward controls. The media controller package allows you to program the controls you need for your video player application. And this is the control itself that renders the video file. This is the video view widget. This package allows you to be able to render and play video files. So an important one to have. Apart from these packages, you also need a few other ones. These are packages you need within the code base, like the activity class. You have to make reference to it before you can use it. If I delete it, for example, it throws an error because it doesn't exist anymore. When I import it again, it's there and it can be used. So that's how you import packages. You might have noticed this grey-coloured text. It shows up like that because I haven't used those packages in my code base yet. On the other hand, when the package name is in white, it means it's been referenced and the package has been accessed. And those are the major imports you need for your video player application. These include URI, media controller, and activity class, all built-in packages that come with the Android SDK. In later videos, you will be able to start building the application itself, write the code, and ensure that your video file will play on your app. The next video is about the different built-in classes you'll need for your video player app. In a previous video, you pondered the question of why some apps are better than others. Here is a reason. Interactivity. Users want apps that respond to their input. That's why you need a way to manage user inputs effectively, and you do that with variables. Variables can be used, among other things, to enable developers to capture user inputs to create a more interactive user experience. In this video, you will learn how to declare variables and how to display their values on screen. You can temporarily store data using variables. The data stored as variables can be changed and reused depending on the condition or on information passed across the application. To declare a variable in Kotlin, you use the keyword var or val. Let's unpack the syntax. Var or val implies that you are creating a variable. Next is an identifier or the name that you give the variable. The identifier is followed by an equal sign, and finally, the value which is stored in the variable. You will learn the difference between var and val later in this video. Let's first explore a few examples of variable types. Kotlin provides a set of built-in variable types that represent numbers. One of them is integer or int. For instance, you can have a variable total count, which is an integer variable and has a value of 25. Another variable type is string, which is a collection of characters. You can have a variable called country as a variable of the string type, and its value can be United States. But say you do not know the value of the variable yet. Fortunately, you can also declare a variable without assigning a value right away. However, this is only possible if you specify the type. Let's declare a variable with an identifier called color, and set the data type as string. Because you already specified what the variable type is, you are allowed to assign the value of color only in the next line. Next, let's focus on the difference between var and val. A variable declared using the val keyword cannot be changed once the value is assigned. For example, if the variable country was created using val and a value of United States of America was assigned to it, it will generate an error if you try to assign United States in the next line. On the contrary, when you declare a variable using the var keyword, the value can be changed later in the code. So, if the variable country is created with the var keyword, no error will occur if the value is reassigned later. Lastly, let's focus on how to display variables on screen. To perform special tasks, such as displaying a variable, programming languages use something called functions. A function is a unit of code that performs a special task. To display a variable on screen in Kotlin, you use a printline function, like many other programming languages. To write a printline function, you type println followed by a set of parentheses. You then add the variable identifier in between the parentheses. This line of code will let the value of the variable display on screen. Let's explore a few examples of the printline functions. Say you have a variable first name that has the value of Michael, and in the next line, the printline function that includes the word hello, a space between quotation marks, a plus sign, and the variable first name. Hello Michael will be displayed on screen. You can also have two additional variables, last name and full name, which combines two variables, namely first name and last name. Notice that a plus sign can be used to combine the values of two string values as a single string. The printline function will let the first name and the last name display on screen. In this video, you were introduced to different keywords that you can use to declare variables. You also learned about different types of variables and how you can display variables with the printline function. You're almost ready to start creating your player. But first, there are a couple of important things you need to be aware of. You will use Android's Video View class. It will be used to display a video file in your application. You will need another component named Media Controller as well. It will provide you with the playback controls of the video player, such as play, pause, backward, and forward to control the video player. And with the combination of Video View and Media Controller class, you will be able to create your video player. Now, let's move on to what you need to do to actually create your player. As you follow along, keep in mind that this is an overview, so it's okay if you don't understand everything that's happening in the code. I'm now going to create my video player. In the IDE, I already have the video I want to play in the raw folder. Because I generated this project from a basic activity template, I have an activity_main that has been automatically generated. And I have the main activity class as well. So, all that's left to do is to start writing code. I'm going to have to access the video view player in the activity_main file because it's used to play the video in MP4 format. So, I need to make a reference to the controller here in the UI interface. When I go to the Design tab, you'll notice that right now the interface is blank. But let me get back to the code. From the code base, which is the XML equivalent code for the UI, I need to start writing something. Here is the code for the video view controller that I'm going to use. And here is a unique ID, test view. I can choose to name it anything I want, but for now, I'm calling this test view, and it's there to manage the rendering on the UI. These are properties you have to define to ensure that the UI is properly rendered on the interface. Here, you can notice how the video view I just added to the XML displays in the Design tab. At this point, I can't do anything with it yet. I have to program it and make sure that I can play and pause. But before I can do this, I need to go back to the main activity class. This isn't doing anything right now either. I have to make sure that the video view player in the activity_main XML can respond to user inputs. So I have some code for that. But before I start writing anything, I want to discuss a function named onCreate. onCreate is used for the main activity. It is the entry point of the application. When the app runs, this is where it goes first, the onCreate code snippet. I'm going to put my code after setContentView because this is going to set the content, the activity_main I just created. So I'm going to put my code here after this line when the content has been rendered by the compiler. Let me explain the code step by step. This is a reference to the video player I just created in the activity_main.xml. This is a test view. I make a reference to the test view, and that's why I have declared a variable here named video view. What I want to do is find the property. It should examine all the view groups that have this test view property, and then retrieve it and store it in the temporary variable. Once this is in place, the next thing to do is to create an instance of Media Controller. Media Controller enables me to have control over the video view player. So if I want to play, pause, or forward, the Media Controller handles those activities. Now that I have this one in place, handling the activities, I need to make a reference to the location of the file. The MP4 video that has to be accessed is inside RAW. With the URI, I have access to the directory or the location of the file I want to play. This code snippet is performing the operation, which is why it's needed in the code base. The next step is to play the video. I need to be able to set the controller you just created to video view. That's because I want video view to have control over the media controller. I'm setting the controller to it, meaning that this controller is specifically for this video view. So, if you have two other video views within the same UI, you'll have different controllers for them. After this, the next step is to set the location of the video I want to play. And that's the URI here. I've already set the variable here, and I've set the value as well. So now we are saying that sets the video URI, which is here. The next step is to ensure that there's a focus. That's why I'm using request focus here. This reference is a function that allows you to be able to start the video immediately and then focus on the controller of which we have the last phase, which is on end start. All these things are basic configurations you need to have in place before you start the video itself. I'm going to start the emulator now. Let's examine what it looks like there. I'm just waiting for it to come up since it's busy installing the application. So, here's the video playing right now. And this is the controller. If you tap on this to focus on the video, then the controller will pop up. You can pause, play, and you can forward. And there you have a video player. I hope you enjoyed this walkthrough of the process of creating the video player. First, I added the video view to the XML, and I made sure that the video view player can respond to user inputs. Then I used onCreate to make sure that the application starts at the right point, after which I referenced test view, created an instance of media controller, and made reference to the location of the file. After that, I set the controller to video view, used the URI to set the location of the video I want to play, and used request focus to start the video immediately and focus on the controller. And remember not to worry about knowing everything that's happening in the code at this point. You will have the opportunity to deepen your understanding in later courses on Kotlin, where the code is explained in more detail. Now, it's time for you to give creating a video player a try. Well done! You've reached the end of this module on Android mobile app development. Let's recap the key points and skills related to building a mobile app in Android. You began this module with a lesson on the requirements gathering process and its role in project planning and creation. Project planning is crucial to the efficient development of effective apps. You then moved on to explore the project templates available to you in Android Studio, focusing on the basic activity templates that can be used to create the base code for your video app. You also learned about components you can add to this base code, such as clickable buttons and a video viewer. Next, you explored the process of starting the video player project in Android Studio. You began with template selection and ended with selecting the software development kit, or SDK, which is the minimum Android version needed to run your app. You should now be able to recall and perform these steps and other steps to create a base project using a template in Android Studio. You were then introduced to the Video View class, an Android Studio component used to display video files. Then came setting up the app screen, concentrating on the main activity. Remember, an Android app contains one or more activities, and each activity is one app screen. The main activity is the first screen that is displayed when a user launches the app. These screens contain user interface or UI components, the structure of which is defined by layouts. You learned that UI is made up of views and view groups. A view represents a rectangular area of the screen and a building block of UI, such as text, images, or buttons, and view groups are like a container for views that define the layout in which these views will be arranged on screen. You discovered the different layouts written using the Extensible Markup Language, or XML, in Android Studio, including the linear layout, relative layout, list view, and web view. You also learned how to declare a layout through a simple XML layout file located in the resource layout folder of the app project. The next step involved familiarizing yourself with Android's built-in class for locating files, the Uniform Resource Identifier, or URI, and how to use URI to locate a video file. You also discovered how to use import statements to access helpful Android SDK classes such as the Video View class, as well as URI, Media Controller, and Activity class. You were introduced to variables that can hold values such as integers or strings as a way for developers to capture user inputs to create a more interactive user experience. You declared these variables in Kotlin using the keywords var or val. A variable declared with var can change, whereas a variable declared with val is immutable, and the value cannot be changed or reassigned. Variables can be displayed with the printline function in Kotlin. For example, displaying a variable called firstName with the value of Michael along with hello so that the app displays Hello Michael. Finally, you were walked through the process of creating a video player, from adding video view to the XML to using URI to set the location of the video files you want to play. You should now be familiar with the essential skills and concepts of Android mobile app development, including how to create your own video player app in Android Studio. Congratulations! That's great progress towards becoming a skilled Android mobile app developer. Now that you've completed your introduction to Android mobile app development, let's recap what you've learned. You began with an introduction to the program and course. You gained insight into the roles and responsibilities of mobile developers, from designing, building, and maintaining mobile apps to project planning and research, and discovered essential development skills like programming languages. Whether joining a company or freelancing, you explored different careers for mobile developers and in Android development specifically. You then downloaded and installed the Integrated Development Environment, or IDE, used for developing Android apps, Android Studio. When exploring mobile platforms, you learned that mobile apps are installable software that runs on mobile devices. You identified some advantages and disadvantages of mobile apps, such as being faster than mobile websites, but more expensive to build. You also learned about mobile operating systems, which allow mobile devices to run apps. and Android platforms like Chromebook and Android TV. In your introduction to Android development, you learned about Android programming languages, focusing on Kotlin, the preferred language for building Android apps. Benefits of Kotlin include conciseness, readability, and easier maintenance, as well as interoperability with Java. You toured Android Studio, learning about some of its key features, such as a build system that allows you to compile and build your Android apps. You also examined the toolbar, navigation bar, and project window, editor window, tool window bar, and status bar. You discovered different project templates in Android, like the basic activity and bottom navigation templates. Some of their uses, such as providing a code base to work from when developing apps, to adding activities to existing projects, and the advantages of using them, such as building functional apps quickly. You learned that with the Android Software Development Kit, or SDK tools, it's easy to start a new project with a set of default project directories and files. After that, you were introduced to the major components that make up Android apps: activities, services, broadcast receivers, and content providers. You learned that the Android manifest.xml configuration file defines these major components and their interactions and contains information about what an app needs in order to run on an Android device. You were also introduced to how to define the components within this XML file. There was an introduction to emulator software, the computer programs that allow you to test your apps on simulations of the devices they've been designed for. Next, you learned about and examined the interface of the Android Virtual Device, or AVD Manager, an Android Studio feature used to ensure your Android apps are optimized for different devices. After that, you were introduced to the Android operating system, or OS images, which are versions of the Android operating systems used by an emulator. You learned how to access these OS images by creating and configuring a device with Android Studio's Virtual Device Manager and explored some AVD properties commonly used when configuring an emulator. As you moved on to exploring the Android Studio IDE and project structure, you examined the structure of an Android project. You learned about the folders and files that contain everything required for an app to run, such as the root directory, which is the root for all other folders and files, and the .gradle folder, which is essential for project building. You also learned about the main activity class, which is generated alongside these folders and files when creating an app in Android Studio and contains Kotlin code integral to app behavior. The onCreate function in main activity was identified as the entry point for your app to run successfully. After that, you delved into Gradle, which manages the Android project through a set of build configuration files. For every Android project, you learned 2 build.gradle files are generated. The first, whose settings apply to every module in the entire project, and the second, whose project level or module level settings apply only to the app module. You discovered the structure of a default build.gradle file and explored popular Gradle commands that give you more control over the Gradle system, such as the Gradle build command. You gained more insight into the Android manifest file, an XML file that contains essential information about your app. You learned about the resources contained in Android Studio's resource folder, such as files and static content your code uses. Like colors and animations, you can reference these resources anywhere in your app code. You also examined the res and layout folders within the project files. These help your app render high-quality images across different devices and manage user interface or UI of your app. Finally, was the setting up your project and preparing for building a video player app. You started by exploring the importance of project planning for successful app development and using requirements gathering to decide which built-in controls like project templates to use. You were introduced to layouts in Android Studio and how they are used to structure app UI, including setting up the screen that appears when an app is launched. To use these layouts, you need to declare them using a simple XML layout file in the resource layout folder of any project. You also discussed some commonly used templates, such as the basic activity template. You learned more about the Uniform Resource Identifier, or URI, a built-in class specifically for locating resources, and how to use import statements to access helpful classes like this one within the Android SDK. You were introduced to variables as a way to capture user inputs and create a more interactive user experience. You learned to declare variables in Kotlin using the keywords var or val and to display them with the print line function. Finally, you had the opportunity to follow along and create your own video player app in Android Studio using Android's Video View class and the Media Controller component. Well done! You have covered many concepts and skills and gained significant Android mobile app development knowledge during these courses. Best of luck as you try out what you've learned. Congratulations on reaching the end of this Android mobile application development course. You've worked hard to get here and developed a lot of new skills during the course. You were able to demonstrate some of this learning and practical mobile development skill set by creating a video player app. Now that you've completed this course in Android development, you should now be able to understand the general principles of mobile apps and the Android platform ecosystem, set up and explore the Android Studio environment, and create and modify your own video player app. So, what are the next steps? Although you have covered several key areas in Android development, you may realize that there's still more for you to learn. If you found this course helpful and want to discover more, why not register for another? You'll continue to develop your skill set during each of the Android developer courses that are a part of this program, and in the final capstone project, you will bring together and apply all the skills you've learned. Even though you're just starting out on your journey to become a mobile developer, you have gained a valuable understanding of the concepts and practical skills you will continue to learn as you progress, and the tasks you have completed in this course has helped to consolidate your knowledge thus far. Well done on taking the first steps towards a future career. And once you've completed all the courses in this program, you'll receive certification in Android development. This certification can also be used as a progression to other role-based certifications. Depending on your goals, you may choose to move on to advanced role-based certifications or take other fundamental courses once you earn this certification. These certifications provide globally recognized and industry-endorsed evidence of your technical skills. Thank you. It's been a pleasure to embark on this journey of discovery with you. Best of luck in the future.